All right, good morning, everybody. I hope everybody enjoyed their first long weekend. Welcome to Math Lesson 3, talking about using money to illustrate place value. So let's jump right into that, okay? The main thing to remember is each digit in a number has what they call a place value. And here it's explained. The value of a digit depends on its place or position in the number. And there's lots and lots of place values, but we're talking about the first three right now: ones, tens, and hundreds. And they're going to be referring to money on this because it's the easiest way for fifth graders to kind of get it all straightened out in your head. So if I had a 6 on the first place here, that would be the same as 6 ones, right? But if I took this 6 and moved it over here, now it's worth 6 tens. Well, how much money would be 6 tens? And hopefully you can know that's $60 or 60, right? And if I move that 6 way to the left, now it would be worth 6 hundreds, right? Or 600. That's all they mean by place value. Where the digit is determines its value. So let's jump right into some questions right now. Here they're going to ask you, in $483, which digit shows the number of tens? And if you truly can't figure that out, my advice, write 3 little lines like this and just go ahead and write the number that they're talking about. 4, 8, and 3, right? And just a reminder, when they're talking digits, it's just a fancy word for the single numbers. The digits to choose from are 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? So now let's go back and look at this question again. In $483, which digit shows the number of tens? Well, that one's pretty easy, right? Which digit shows the number of tens? The 8 shows it. Which digit shows the number of hundreds? Well, in the hundreds place, I have 4. That's all the place value really means. You have 4 hundreds, 8 tens, and 3 ones, right? Not too tough so far, even for a Monday. Now we're going to run into a problem like this. Use digits to write 8 hundreds plus 4 tens plus 6 ones. The first thing you probably want to ask yourself, am I only showing digits on these type of problems? Because later on, they're going to throw 2-digit numbers or 3-digit numbers. But in this case, that's only one number, that's only one number, and that's only one number. So you can just go ahead and plug them in your lines, right? 8 hundreds. So let's put a 8 on the hundred place. 4 tens, well, let's go ahead and put a 4 on the tens place. Plus 6 ones, let's go ahead and put a 6 on the ones place. So to answer our question, we have 846 is what we should have written down, right? Check this one out. How much money is $300 bills plus 11 $10 bills plus 13 $1 bills? We don't have single digits here, right? 3 is, but check this out. 11 is not. And 13 is not. The only things that can be written on these lines are those 10 digits. You can't put an 11 here in the tens place. You can only use your single digits. So we got some more thinking to do. So let's go ahead and think this through. Let's start here. $300 bills. Well, that sounds like $300 to me, right? That's not that tough so far. So let's get 300 written down here. But here's where it starts getting tricky. 11 $10 bills. Well, hopefully everybody can count by tens, right? We practice that in mental math. And if you did it again, counting by tens 11 times, you would go up to 110. And now 13 $1 bills. I don't think there's a fifth grader out there who doesn't know 13 $1 bills would be 13, right? So then you got to go ahead and add those numbers up. Let's take a look. 0 plus 0 plus 3. Hey, that's going to give us 3. 0 plus 1 plus 1. That's going to be 2. And lastly, 3 plus 1. Hey, that's going to give us 4. So how much money is it? $423. And please don't forget to put in your dollar sign, okay? Let's keep moving. Check this out. What number equals 6 $10 bills? Well, that wouldn't be too tough. If I had a 6 right here and I count up by tens, you should be able to know 6 $10 bills. That would be $60, right? 10, 20, 30, 40, 50, and 60 if you had to count it up. I don't care how much you don't think you know math. Let's take a look at this one. What number equals 8 $100 bills? Well, if I had 8 in the hundreds place, count it up by hundreds like we were doing in mental math, and you're going to end up with $800, right? 100, 200, 300, 400, 500, 600, 700, 800. Let's keep moving on. Check this guy out. Here they're asking us, the greatest two-digit even number is 98, right? And I kind of wrote it out here to explain. 98, if you want to start off by making yourself two lines, and they're talking about the greatest two-digit even number. And we learned back on math lesson 2 that the last digit here determines whether a number is even or odd. So for the digit in the ones place, I gotta use the greatest even digit. The greatest even digit is 8, right? Here's your digits again. The greatest even digit was 8. But they also wanted to know the greatest two-digit number. So now what's the greatest digit I have? 9. Do you understand how 98 is the greatest two-digit even number? So let's go and look at the question now. They want to know what is the greatest two-digit odd number. So for the digit in the tens place, use the greatest digit. What's my greatest digit? It's got to be 9. But now I have to make it the greatest two-digit odd number. What's my greatest odd digit? Hey, it's 9 again, right? So the greatest two-digit odd number is 99. And they're going to ask you questions like this every day for about a month. So you better make sure you understand this now. If you don't know how I did this, I implore upon you to back up and listen to me again. Let's take a look at another one. What's the smallest three-digit odd number? I gotta think of the smallest. I gotta use 3 digits this time. And my last digit has to be the smallest odd number. So here's my digits again, right? 0 through 9. So let's fill in the first one, the smallest odd digit. Not 0. 0's even. The smallest odd digit would be 1. What's the smallest digit I can put in the middle of a number? Well, that would be 0, right? But check this out. Sometimes 5th graders stumble on this. What's the smallest digit I'm allowed to put at the front of a number? It's not 0. You never, ever, ever start a number with the digit 0. The smallest digit I can put in the front of it is 1 again. So to piece it all together, what's the smallest 3-digit odd number? 101. Again, they're going to be asking you questions like this for about 30 lessons. If you still don't understand how I'm doing this, hit rewind and watch and listen carefully. Let's take a look at this one. Here it says 10 $1 bills has the same value as 1 of what kind of bill? Well, if I had 10 $1 bills, how much money is that? Hey, that's $10. $10 would be the same as 1 $10 bill, right? So, has the same value as 1 of what kind of bill? 1 $10 bill. Check this one out. What number equals 6 tenths? Now, they aren't really necessarily asking for money here. They're having you bridge the gap from thinking of it as money to thinking of it as regular numeric place value. But it works the same. So, as a 5th grader, I advise you thinking about money. 6 tenths. I had 6 of these guys. Let's go and figure it out. If you don't know, let's count up by tens. 10, 20, 30, 40, 50, 60, right? And so what number equals 6 tenths? 60. And all 60 means is that you have 6 tens and you have 0 ones. Let's try it again. What number equals 7 hundredths? So just like we did in mental math, even if you can't figure it out, I saw everybody count the other day, right? 100, 200, 300, 400, 500, 600, 700. $700 or 700 the number just means you have 7 hundreds, you have 0 tens, and you also have 0 ones. 700 is the number they're looking for. Check out this one, and this is really, really important, and it's based on a question you're going to have today. And if anybody raises their hand and wants help, I'm simply going to say you better get your iPad out and watch that part of the lesson again. Here they are asking, write a rule that describes how to find the number of tricycles for any number of wheels. We're going to have problems like this for about a month. And the way to figure these guys out, write a rule that describes how to find. This is what they're focusing on. They want to know how to find. What do we have to find? The number of tricycles. So let's take a look at this table. Here I have number of tricycles and the number of wheels, right? They want us to find the number of tricycles. Draw yourself an arrow if you need to for any number of wheels. And it's kind of confusing, but if you focus on these words, how to find, that's where they want us to end up. They want us to end up at the tricycles. Sometimes the arrow's going to be going down, sometimes the arrow's going to be going up. But they want us to find the number of tricycles for any number of wheels. So I'm starting with 3 and I'm ending up with 1 tricycle. Or if I had 6 wheels, I would have 2 tricycles. Or if I had 9 wheels, I'd have 3 tricycles, and so on and so on. I think I have enough here. The trickiest part is trying to figure out what direction to think about an arrow. I want to find the number of tricycles for any number of wheels. So I'm starting with 3 and I'm ending up with 1. Or I'm starting with 6 and I'm ending up with 2. And I'm starting with 9 and I'm ending up with 3. What is my rule this time? And I'm hoping people paid pretty good attention last year because I haven't talked a whole lot about this. This is not count up and it's not count down, right? Because, yeah, you could count down by 2 to get 1. But if you are on 6 counting down by 2, that doesn't give you 2. And 9 counting down by 2 doesn't give you 3. What are you doing to these number of wheels to find the number of tricycles? The rule is divide by 3s. That's your rule. Again, not too tough when you spell it out like that, but you gotta make sure what direction your arrow is going in order to find the rule. Okay, let's move on. Check out this one. How many tricycles are represented by 24 wheels? But Mr. Hines, my chart only goes up to 18 wheels. Fair enough. So you're going to have to extend this chart out and do it on a scratch piece of paper. Do not be writing in your book. Let's take a look at this top row for a second. 1, 2, 3, 4, 5, 6, 8. I'm just counting by ones, right? That's easy, so I know this next one would be 7. I know this next one would be 8. And I know this next one should be 9, right? Let's take a look at the bottom. 3, 6, 9, 12, 15, 18. What's my rule here? What am I doing to each of these numbers? We covered this way back in lesson 1. Looks to me like I'm counting up by 3, right? So let's keep counting. 18 plus 3 more, that's going to be 21. 21 plus 3 more, hey, that's going to give us 24, correct? And 24 plus 3 more, that's going to give us 27. I think I have this extended out far enough. How many tricycles are represented by 24 wheels? Well, 8. 8 tricycles if you have 24 wheels. Let's keep moving on. If you didn't understand that, you better hit rewind, correct? Okay, so that's all I have to share with you today. You might want a piece of scratch paper for your Socrative quiz.